Today, I'm sitting down with Saman Farid, the founder and CEO of Formic. Formic works with more than 20 robotics manufacturers and provides robotics as a service to small and medium-sized manufacturers in the United States.
You typically might expect 6,000 hours is like a relatively full production schedule. The average American factory runs about 2,000 to 3,000 hours.
Now, the company has deployed robots in more than 100 factories, so there's no one better to speak to than Saman about the current state of affairs of robotics in the United States. No fluff, no headlines, just the reality from on the field.
We take care of all the engineering, installation, management, maintenance of the robot.
I hope you enjoy the conversation. Remember to go direct. Hey, my friends, Jordan here. Just a few words before we hop into today's episode. First and foremost, a sincere thank you and appreciation for all of our early listeners, readers, and supporters at Going Direct. It's really what keeps me going to do this each and every week, because there's clearly a community of folks out there looking to build a Going Direct economy, which gets me super excited. Secondly, if you haven't subscribed, please do so. Our main channel and community is forming over on Substack. The link is in the show notes below. And we'll also be putting out our weekly conversations at YouTube, Spotify, and Apple Podcasts. I hope you all have a great day. And remember to go direct. I will listen to Saman. I appreciate the time. And I think, I'll kind of frame this up and then we'll hop right into it. So as everyone that's watching or listening knows, the whole idea behind Going Direct is how do we build this kind of going direct economy, which is about decentralizing the real economy. How do we start making stuff closer to where we consume them? How do we become more connected to the people that make them and what's actually inside of them? And so obviously decentralized production is the core of this. In order to do that realistically in the West, we're going to have to incorporate much robotics and automation and create more decentralized production capabilities. And so one of the biggest things there and kind of my dream for the future that I want to help create is how do we really recreate a robust network or much bigger network of small, medium-sized manufacturers. And I've followed your work for a while and Formic's work for a while, which is why I reached out. And I think the biggest thing that always drew me to what you were doing before all of this momentum in the last 4 or 5 years in the robotics space was you were really addressing this deployment gap that exists, that has existed in the past and will continue to exist for next generation robotics. So, and the last thing I'll say, then we'll hop into it, is, most of folks that I've spoken with are largely in the lab and working on a lot of these next generation technologies, maybe working at pilot phase with a few customers, versus you and your team are literally in, is it 100 factories? Is that right?
That's right. Yeah.
Yeah. So, I mean, you have a very interesting perspective of what is the true game on the field. And so, so I'm excited to hop into it. All right. So I want to start here with a tweet from a couple months ago from you. All right. And I'll let you take it from here.
Sounds good.
Okay, so I'm reading here. So you wrote, factory tours should be a mandatory part of middle school education on up. Knowing where the stuff you use comes from is such an awe-inspiring thing. It builds an appreciation for labor, design, engineering, scheduling, and so much more. So that's like a very, very interesting perspective. Love the perspective, obviously, but kind of tell me why that's something you believe in.
So first of all, thanks for having me on. I'm excited to be here. I think, in reference to that tweet, there's so much complexity that goes into every single everyday object that we don't appreciate, right? I think every motor has magnets and windings and bearings and all this amazing complexity, controls. Every object that we use every day is made with like enormous dedication in engineering, manufacturing, production, supply chain. It's kind of scheduled for all those parts to arrive at the right place at the right time, logistics to get it to the store near your house. And you can go down the street and spend $5 to buy, the most complex object in the world. There's an interesting article. I can't remember the name of the guy, but this famous economist said basically there is not a single person that exists on planet Earth today that knows end to end how even something as simple as a pencil is made. If you talk about the graphite that goes in the lead, you talk about the wood.
It's Milton Friedman.
Milton Friedman, yeah. That's right. Yeah, the paint, the metal that goes on the the eraser. Right, like there's so much complexity in even something as simple as a pencil, and obviously the amount of complexity that we have beyond that is enormous. So for me, I think there's just such an important part of the education of every person to think about, what is this world we live in? Where did it come from? How did it get created? What is the kind of enormous amount of cooperation that went into the creation of this world that we're in, right? I think it's easy to talk about competition. It's easy to talk about the other. But at the end of the day, like, human civilization is this thing that is an iterative addition to what other people have done before. And whether that's in science, whether that's in engineering, whether that's in manufacturing or production, like, you just see it so clearly in the production, in the world of production. So obviously a lot of passion around that. And then, the extension of that is, like, if you actually go and see real factories, the other thing that really stands out is there's a lot of small, medium-sized factories, right? So there's obviously the General Motors and Teslas and TSMCs of the world. But for any of them to be able to survive or produce the things that they want to produce, for a single automotive plant, there's like 4,000 suppliers that make, the little buttons that open and close the window, and the windshield wipers and the lights and the seats, and every single component in that is made usually by some third party, oftentimes with a smaller, medium-sized manufacturing business. And those businesses are so, I think today, especially in the Western economy, really overlooked, right? They seem kind of boring or stodgy, or they seem outdated, but they're the spinal cord of modern civilization, right? Like, it's the guy who makes the nuts and bolts and the bearings and the seals and, like, all these things that end up in every complex product. Oftentimes these are small family-owned businesses, multiple generations. In America, it's common for them to be second, third generation businesses. A lot of the time they employ, like, the majority of the people in the town that they're in. And so, they have a critical impact on the economy. They have a critical impact on the flourishing of the people in that city and town. And there's just this stack of things. And, if you start to kind of remove that stack, like, the whole infrastructure starts to crumble. So, yeah, a lot of passion around. I think young people should be aware of this. Young people should be involved in this, should be contributing to this. And I think, it's enormously meaningful. And if I have to hear one more teenager tell me they want to be a YouTube influencer, I'm going to kill myself.
As we're on a podcast. No, I'm just kidding. No, I completely agree. Well, listen, so I'm from Detroit, or just outside Detroit. So everything that you just said, and I think this is probably why it's just in my blood, and it's just what a lot of my work and investing is about. And you said this, which is like, people don't talk about this, and it was like, it's exactly true, but you have to grow up in a place to see it, to understand it, which is like, the companies that sponsored the little league baseball teams and the soccer teams and all the many of the parents that work there, like, we're part of, like, making these physical things, and we're, like, literally the fabric of the local community. And there's just a level of, like, respect and connection and realness to folks that, like, make stuff. That anyway, so I appreciate your perspective on that, because I do share your I guess, perspective and passion for it, and hence why I think we both do the work that we do. So
yeah, absolutely. I think just to echo that, right? Like, I think when you grow up in a place where you see that evolution, my childhood was mostly spent in China. My parents moved to China when I was a little kid. I lived there until I finished high school. So I got to, my dad would take me in and out of factories, but also I got to see China go from, Beijing when I moved there was, dirt roads and donkeys carrying bricks, down the road. Mm. And by the time I left, it's this kind of modern metropolis. And when I saw that evolution over that specific period of time, right, it's this incredible evolution of, like, our ability to produce the things that we need is directly correlated to the quality of life of the people. And just being able to see that transformation happen in real time, I think, like, whether it's a place like Detroit or whether it's, like, an economy that's in the process of developing and modernizing, I think being able to see that firsthand, like, just gives you such an appreciation for how much human ingenuity goes into making the things that we, can walk down to Walmart and grab.
Well, I think it's interesting. I had that down. I thought it was very interesting. You grew up in China, so we'll definitely dig into that. But I think that point, I think you had an interesting view of also what you see happen when there's industrial policy, right? To actually make that a priority for the nation, which is like, well, we'll get into it. But okay, so I have a stat for you.
Yeah.
This is a pretty interesting one. Let me know if you kind of have a similar from your research and knowledge, but I thought this was very fascinating. So in the US, there's somewhere between approximately 240, 250,000 manufacturing firms. 65 to 75,000 have between 20 and 500 employees. So that's about 30% of manufacturing companies in the US are between 20 to 500. But 98% of manufacturing sites have fewer than 500 employees. Is that accurate based upon my research?
Yeah, absolutely.
Okay,
absolutely.
So that is super fascinating. And so what I wanted to ask you was, everyone says, and automation is just around the corner. I'm very excited about the future, but most of these factories aren't automated, obviously. So based upon your experience, kind of explain to me what the core bottleneck is.
That's a great question. And like any good question, it has a very compound answer. Like it's a bunch of things. But I think at the simplest level, there is a operational complexity with modernizing small, medium-sized factories, and then there's a cultural complexity to it. So I'll talk about the operational complexity first because that's easier to understand, which is these factories are typically experts in making their specific product, right? Let's say they're making dog food or chocolate chip cookies or door locks or handles or whatever, right? They know everything there is to know about that product and that industry. To expect them to know everything there is to know about chocolate chip cookies and everything there is to know about robots is just like a really tall order, right? Especially as robots become exponentially more complicated as they have over the last 20, 30 years. And I think when it comes to robots, that's an obvious thing to see. It's even more obvious when you look at, for example, servers, right? And I think that's an analogous technology that I think is worth talking about, where most businesses in the world have decided that they are not best equipped to own and manage their own data centers, right? They said, you know what? I will focus on being an accounting firm and I will just let AWS manage the servers, right? Sure. Or whoever else. And I think it's easy for us to accept that with something like with servers, but for some reason, I think the historical idea is like, oh no, but you should manage your own robots. You should build and figure out how to buy and manage and deploy your own robots. And I think that it's just asking a lot from that. There's also a lot of, in the spirit of kind of going direct, there's also a lot of really poorly incentivized intermediaries that try to sell you crap, basically, right? So if you're a factory, typically the way that you would automate is you would go and hire some expensive automation consultant, and they would come in and they would spend you a few $100,000 of your money doing this kind of study and analysis. And then they would pick probably the most complex thing in your factory to automate, because then they can charge you for engineering services, right? And then they'll charge you a bunch of engineering services to design some super complex, super custom piece of machinery that only works for you. And then they would charge you a bunch of money for the hardware. They would upsell you. The more hardware you buy, the more margins they collect, because it's always done on a cost plus basis. And then at the end of all of that, if you're lucky, it works. But very often, most likely, it doesn't work. And then there's a change order. You get a change order that says, oh, by the way, I forgot to mention, this doesn't work if it's raining, or, oh, it doesn't work if the sunlight is on, it's whatever. And so all of a sudden, you've already spent $500,000 or $1 million or $2 million on this, expensive piece of machinery. What are you going to do? Say no? You just got to keep paying until finally, hopefully it works. So, it's this really horrible experience where there's this information asymmetry between the buyer and the seller. The seller is heavily incentivized, actually heavily disincentivized towards efficiency and standardization. And so whether that's, traditional robotics or modern robotics, you still have the same bottleneck where Factories don't know what they need. They don't know how to buy it. They don't know how to manage it. They don't know how to maintain it. So that's the kind of operational complexity. There's also this kind of cultural complexity, which is I see more commonly in the US than I did when I lived in China. And this is probably a little bit controversial to say out loud. Most American manufacturing businesses are either third generation business, like owned businesses, or they're private equity owned manufacturing business. Very, very few manufacturing businesses in America today are founder owned and operated. And as we know from the world of startups, right? Like when you're a founder owned and operated company, you're willing to take a lot of risks. When you're a third generation manager of the business, oftentimes you're more concerned with preservation of what you have than you are with really pushing the boundaries around capability. It's very hard because you weren't there to build this thing from scratch. You kind of inherited it. It's difficult to go and make very risky changes. And private equity firms, let's not even talk about, like that, even less likely to make aggressive, creative changes, right? And so there's this cultural complexity for manufacturing businesses around trying new things. It makes it really, really difficult for them to adopt modern technologies and to take risks. And if you compound that with the operational complexity, which is like, I'm not even, taking a risk on something I don't understand is even worse, right? So I think historically, American manufacturing has really suffered because it's been difficult for people to do that. You compare that to China, which in the last 30, 40 years has really grown a lot in the industrial. It's super common for you to go to a Chinese factory, and in this room they're making toilet paper. In that room they're making engine parts. In the other room they're making like automotive components. Like there's no rhyme or reason. It may not be a good idea to do all those things under one roof, but like because they're founder owned and operated, like they look for opportunity and then they jump on it, right? Obviously, that's changing as these businesses mature and evolve, but I think it continues to be a point of strength for China that these businesses are willing to take risks and try things, and I think it's a challenge for American manufacturers because it's difficult to do that.
Interesting on that point. So 4 or 5 months ago, I did a podcast with Dylan Patel from Semi-Analysis. I don't know if you know that firm, but they do like really good research on kind of both the robotic supply chain and everything around AI infrastructure. Yeah. And we spoke deeply about like how far ahead China really is ahead of the West when it comes to robotic supply chains. Anyways, what he described, which I thought was a really good way of putting it, I want to get your perspective because you spent a lot of time in China, was he was just basically saying, he goes, the Chinese way, if you think about it, is he goes, basically you have many companies you've never heard of that are listed on the stock exchange over in China who might be literally world leaders in their respective industries. And because of how the system works there, you have companies that are competing with each other to continue to drive costs down. But then what they would rather do to maintain their market share is when they drive that cost down, they don't keep that margin for themselves. They are passing that margin on to their customers and to the market to allow the whole supply chain to continue to function, right? Because everyone downstream needs their margin to make it work. Versus the American way is like, how can you get the highest margins possible? Anything that you can do to bring costs down, you're not passing it on to your customer. You want it all for yourself. And so I thought that was an interesting perspective.
I mean, I don't think it's out of the goodness of their heart that they pass the margin down. I think it's because of this extreme competition, right? It's like if you don't do it, the other guy will. And I think that it comes from a much more vibrant ecosystem where there are hundreds of competitors for kind of any small product. And so I think there's just, in the kind of fitness function of natural evolution, you end up with much more fit companies because they have to fight off hordes of hundreds or thousands of competitors. I think like the tech ecosystem in the US is kind of like that, right? Where a lot of tech companies have historically had to really, really fight to survive because there's a lot of competition, and so they ended up being quite fit from a kind of resilience perspective. Manufacturing businesses in America, if they're still in business in the US in 2026, it's likely that they have some kind of monopolistic advantage, right? Either geography or customer relationships or buying relationship with the government or whatever. Like there's something that allows them to stay in business, which is great for them, but sometimes leads to less intense competition, right? Or there's oftentimes duopoly, or there's 3 options, and so you don't get the same level of competition that you get in China.
All right, I want to move over to the job debate. Not to we could sit here and pontificate on whatever future we think's gonna happen. I think what I wanted to get a better perspective on, really kind of the current state and kind of in the short, medium term of what you're seeing, that a lot of folks that are like robots are going to be replacing jobs, and the other side of the narrative is, well, we can't find enough workers to work in the factories, that they're actually filling jobs. And so can you just kind of tell us what you see as kind of the game on the field as it relates to jobs, and whether it's on the scarcity side and robotics are truly filling that gap, or kind of where that stands to be? It'd be interesting to get your perspective.
Yeah. So I'll give you an anecdote, and then I'll give you my full answer. I was in a factory 3 weeks ago with one of our customers in New Jersey, and they make all kinds of products. I won't go into the details of what they make. The factory has about 165 headcount, so not huge. About 165 employees there. In the calendar year 2025, just to keep those roles filled, they had to hire 250 people just to stay in business. Right, so it's like more than a 200% headcount attrition rate of labor. So I think that gives you a little bit of a sense of like how dire the situation is. For a lot of factories in America, labor cost is obviously a bit of a problem, but more than that, labor availability is a giant problem. And these factories are not able to take on more business because they don't have people who can run this factory for a second shift or a third shift. And so if you're a factory and you're running 1 shift a day, just by simple math, 2/3 of the available hours of the year, your factory is sitting idle and collecting dust, right? You've invested a few $100 million usually in facilities, running electrical, forklifts, machinery, conveyors, all this stuff. And then you leave it idle for 2/3 of the hours. It's just kind of inconceivable, right? And so I think the natural answer to your question is like, if you tell any factory owner that, hey, overnight you can have 3 times more available headcount, would you use them? There isn't a single factory that would say no, right? Like they all want more people. In the lack of our ability to suddenly magically create human beings, we have to create robots, right, that can go and fill that headcount. It sounds self-serving coming from a robotics guy, but there's a lot of evidence that shows factories that automate and have robots actually end up having much higher paid workers, much happier workers, much less workplace injuries, and all kinds of benefits, because they're able to kind of take a lot of those menial, repetitive tasks and automate it. I'll end on one last anecdote, right? Which is I was again at one of our customer sites a few months ago that makes they make like body lotion, right? And there was literally a row of 35 people standing there, and 8 hours a day, their job is to screw the bottle caps onto these bottles of lotion. And, they would do 3 of them, and they would shake their hand because it's so painful, and they would do 3 more. And I would just ask anybody who asks, wonders what is the role? Like, is that really like the best use of a human being? Like all the intelligence and creativity and emotion, and like they're gonna stand there twisting bottle caps. Like, it's just, we could do better as a society.
Well, it's interesting that on that, I mean, I'm clearly on one side of that debate, which is because it's just so obvious for me. But I also find it fascinating when people have this other perspective around this idea of replacing the jobs. Many people I speak to about that are very strong on that have never been in a factory or never actually understand.
Right. If you've seen these jobs, nobody wants them. Yeah.
Well, like this other idea of like actually understanding, like when you have customers and you need to have like the as fast kind of production cycle times as possible, and then dealing, like you said, with people not showing up to work, inclement weather, all these things that it's just like really burden. And like the reality of it is, your fixed costs, your fixed costs. You're paying for everything you have in there, no matter what, you know. And I just don't think people
Yeah.
understand that. I don't know. For some reason, they don't get it. But anyways,
Yeah, and I mean, maybe just to extend that point a little bit more, there's a lot of talk today in in the West and kind of or in the US in particular around, hey, we need to build more production capacity. Let's go build more factories, right? Like we need to reshore manufacturing. We need to build more factories. And, there are obviously contexts where that makes a ton of sense, right? We need to build chip fabs. We need to build new battery production lines and things like that. But like the easiest way to get more production capacity is to increase the utilization of the 250,000 factories that we already have, right? Like how many factories can you build in a year in a country versus how easy would it be to increase your utilization of existing factories by 30%? You get much more benefit out of doing that from a kind of overall capacity perspective.
Do you have any data? Actually, it'd be an interesting thing that I haven't seen data on the overall utilization rate of U.S. manufacturing facilities. Do you have any idea what that kind of is broadly?
It averages about 3,000 hours a year out of 8,600 possible production hours. So 8,600 is if you used every minute of the year, right? If you take away weekends and holidays and things like that, you typically might expect 6,000 hours is like a full, relatively full production schedule. The average American factory runs about 2,000 to 3,000 hours.
Wow. So basically half, if that's even being like gracious. Okay. Interesting.
Yeah.
Okay. So let's get over to robotics as a service. So I'm just going to give the formal description from the website, then I'll let you take it here and we'll dig into it. So digging into it. So Formic delivers fully supported robotic automation at a low hourly rate, including deploying the system and providing continuous monitoring and maintenance throughout the engagement to ensure success. So the concept of as a service, obviously most folks are familiar with it, but it's kind of it's used a lot. So kind of could you just break down at a high level, obviously that explains it, but a little bit more about actually what Formic does?
Yeah. So what you described is the product that we offer, right? Which is the easiest way to get robots into your factory, right? So they call Formic, we show up with the robot, and that's literally all they have to do. We take care of all the engineering, installation, management, maintenance of the robot. And what we believe is that is also the best way for factories to automate because number one, it aligns incentives. We talked a little bit about incentives earlier. Number two, it's the only way for factories to get a robot that has a SLA attached to it, right? Like there's some performance commitment associated with that system. Which is typically not the case with traditional robots and automation. But to answer the question more fully around like what does Formic do, in order to deliver on that promise of easy automation, easy robots, we had to build a ton of software to evaluate the factory, figure out which robot is the right one for the job, spec out the hardware, use the software to automatically program the robot, use machine learning models to make it resistant to all the different deviations that might occur in that manufacturing environment, build software for monitoring and maintenance, remote teleoperation, error handling, error recovery, component monitoring for failures and dynamic redundancies and things like that. So we've had to build a ton of software infrastructure as well as a ton of operational infrastructure. We've had to build a nationwide network of installation crews, maintenance crews, supply chain of hardware. And we also had to build a bunch of financial infrastructure to kind of fund and build these things without digging a giant hole for ourselves. It takes a lot of behind the scenes work to be able to offer this relatively simple product, which is, hey, show up and we'll drop in a robot and it'll work. But that is kind of the point, right? Which is like the end customer is not going to do that on their own. The chocolate chip cookie factory, an example. And so you need somebody to basically say, I'm going to take all that complexity, I'm going to abstract it away for you and make it very easy to consume. And that is what's allowed us to get into, to your point, 100 plus factories in the last like 3.5 years that we've been in operation.
Great. And then, so who owns the robot? How does that work?
We own the robot. Yeah. So we are the
Okay,
owner operator of the fleet of robots.
Okay, great. So if I have a bottle, I'm just making this up, right? I have a bottling facility. Let's keep it simple. I have a bottling facility. I work with you to. I'm looking for some automation around some functions around different bottling. You come in, and you basically do an assessment, you analyze, and then you say to me, what, like, I'll deliver you this robot, take care of everything, and I'm charging you X number of dollars per hour that you're using it, or like is it a per month charge, or how does that actually work?
Yeah, the details of the contract vary a little bit depending on the type of product, but sometimes it's a monthly rate, sometimes it's an hourly rate.
Okay.
But yes, basically what you described is correct, which is our sales team shows up, we use a LiDAR scanner to scan the entire factory. We generate a 3D model of that factory. We also have, during that scan, we have a normal camera that observes all the human work that's being done. We quantify all those tasks and say, okay, hey, this task is being done today by a human at a rate of 5 items a minute. That task is being done at 25 items a minute. The boxes look like they're roughly this size and this dimension. The bottles are roughly this weight, and we have to kind of guesstimate a lot of things.
Yep.
But information collection about the factory and about the task is step zero for building and deploying a robot. That's something that I think most robotics companies totally miss, right? They say, oh, if somebody comes to me and tells me exactly what they need,
sure, then
I can deliver my humanoid, or I can deliver my forklift and whatever, and it'll work. The problem is the end user doesn't know what they need. They don't have usually most of that data that I just described. The reason we have to collect it is when we started, we would just ask the customer, hey, what tasks do you do? What rate do you do it at? What's the size and weight of your product? And they don't know. As great. So because they don't know, what are you going to do? You're going to, we realized we basically had to build a bunch of software for kind of analyzing the product, analyzing the facility, analyzing the tasks. And then to your point, we have a matching algorithm. We have a bunch of robots in our library that are kind of standard hardware solutions. The software will pick one of them. It'll run that robot in simulation in that physical footprint with that specific product, with that specific rate, and validate that it can meet those performance demands. That allows our sales guy who's on site to generate a quote within 5 minutes and says, hey, I have a robot. It's roughly this size. It's roughly this footprint. It needs this kind of power line dropped. And it's going to be $5,000 a month, or $25,000 a month, or $500 a month, right? Depending on the type of thing. If the customer says, hey, yeah, I want one, a few weeks later, we show up with that robot. We typically within 4 hours, it's fully installed and operational. We then stay usually for a day or two and do training of the customer to ensure that they can know how to run it. And they're off to the races. And then we take care of all the maintenance and spare parts and things.
And that's all part of that monthly or hourly fee, or okay.
That's right. Yeah.
How many manufacturers are you working with? Like, what does that catalog kind of generally look like from a quantity standpoint?
Yeah, it's 100 plus manufacturers.
Oh, wow. Okay. And so when you think about kind of building all that kind of middleware or kind of software to kind of make everything work, all of them are already kind of open for that anyways. That's how they have to do it today, right? Working with systems integrators to integrate into the core basically operating system of the factory, correct?
Yeah. Sorry, you were talking about how many manufacturers of robotics we work with. That's a smaller number, so I thought you meant customers. Yeah. On the robotics side, today we have maybe 20 or so types of robots in our catalog. We're adding new tasks kind of on a constant basis. To answer your question, yes, partially there are some open protocols that we can use for communication with the different kinds of hardware. But there's a lot of work that needs to be done to make them performant at the rates and capabilities that we need. So for example, you can buy a robot arm from KUKA, but the arm by itself doesn't do anything. So you need a work cell that's built and designed around it. You need end-of-arm tooling, you need sensing, you need cameras, you need safety scanners, you need emergency stop buttons, a whole bunch of different things like that. You also need communication. So you need to kind of build that full work cell and have that be a standard. On the software side, the KUKA robot might come with its own path planning capabilities, but generally it's very limited in terms of the types of dynamic tasks you can ask it to do. And so you still have to integrate it with your camera, your vision system, whatever machine learning models you have, whatever task management system you have, right? So for example, this factory might want me to use that robot to do this, one type of task. A different factory might need me to use the same robot to do a different task. So we have to build kind of the operating system layer that runs on top of the robot and manages all the kind of components to get the job done. So there's quite a bit of development work involved in adding a new category of task, but each incremental task gets easier and easier because it's relatively a standard library of things.
Got it. And is there kind of a core, when you think, is there kind of a core task or core type of customer that you work with, or is it pretty wide ranging?
Yeah. So today, the 5 main tasks that we do are, we do a lot of palletizing, which is kind of end of the production line. We do case packing, which is putting items into the production line. We do autonomous forklifts and AMRs for kind of moving product around the factory. We do a lot of machine tending for mills and lathes. So there's a lot of metal fabrication facilities that need there's kind of CNC machines managed. So we have robots load and unload those things. And the last one that we do is plastic injection mold tending. Again, so lots of plastic injection molding machines are underutilized. You put a robot in front of it and you can get triple the throughput out of that machine.
Cool. All right, let's move over to the financing side, because I thought this was I think it's really important. Because I always like talking to folks. You essentially have kind of 3 businesses in one, which is pretty interesting. I'm sure nice and challenging. So before I hop to the financing, I had one question. Yeah. Actually, as you guys thought about building out your actual integration crews and support crews and maintenance crews, are they all Formic employees? And did you kind of do it from initially from a specific geographical area? How did you think about building that fleet out of technicians and maintenance folks?
Yeah. So we did take a geographical approach, right? What we tried to do is build geographical density region by region. Once we built a certain amount of density, we were able to kind of fund with the kind of robots that are in a region, the field service team, the deployment team, and engineering teams that you need for that system. As we've gotten bigger, that's become less and less of a concern because now we basically have coverage over the whole country and we can basically add new robots to the fleet without necessarily incrementally adding a lot more headcount. A lot of the work there is also building tooling to give those people superpowers, right? So how do you allow a field service engineer to manage 100 robots by themselves instead of 10, right? And that requires obviously a bunch of software, infrastructure, and tooling. But to your point, we are building kind of 3 companies in one, and managing like an operational field service team is not the kind of thing that a typical software company would have had to do. But again, going back to our philosophy around like this is what's necessary to make robots consumable by the end user, right? Like that, the biggest problem around robotics is adoption, sure, not around making the robot do a new trick. And so, like to your point, we needed to solve a bunch of these kind of. So yeah, geographical density is a big part of it. Partnerships is part of it. Although partnerships is difficult to do when you're a young startup because you can't get the performance quality from a third party that you can from yourself. You also can't get adoption of tooling and things like that as well by third parties. But as we've gotten bigger and bigger, we've actually been able to force much better kind of performance across third party. And then there's also other kinds of logistical things, right? Like where do you store the spare parts? How do you ship things around? Do you have trucks or not? You have to kind of build all that stuff in mind.
Got it. Great. All right, so let's move over to financing. So obviously the whole as a service model is obviously it removes the upfront cost for the customer. And you kind of, I heard some quotes kind of, is your kind of whole perspective was this was the biggest barrier to automation adoption is the financing component. Now that you're 5 or 6 years in, do you still believe that to be true? Or is it a mix? It's really a mix of things an equal footing.
Yeah. So I want to clarify that I don't think financing by itself is the bottleneck, right? I think most factories can go and get a lease on a forklift or they can get a lease on a CNC machine. Like that part is actually quite easy. The hard thing is balancing the risk between what the end user is responsible for and what are you responsible for. And financing is a way to relatively cleanly bundle together a bunch of complexity into a simple monthly payment, right? So now the customer pays me a few $1,000s a month. That includes hardware, software, maintenance, spare parts, engineering, installation, and all these other things. And so in order for us to be able to do that sustainably as a startup, we had to solve a bunch of complexity behind the scenes around how do you effectively finance large scale assets. Luckily, these are all revenue generating assets. Right? So with enough performance history, we were able to prove to all of these different financing parties, hey, look, a robot typically has a return profile of X. It typically has a retention rate of Y. It typically has a renewal probability of Z. Right? Like with all of this, it has a redeployment and residual value of whatever. And you have to kind of build that case and build that performance history to be able to get access to institutional private credit, basically, right? And that is the way that historically, data centers were financed. Today even still, like all kinds of infrastructure projects are financed this way. But you have to have a certain level of basically all of your kind of paper has to be finance grade, right? And so like that, there's a lot of complexity around how do you do that and how do you have backup, servicing, and how do you manage taxes and how do you manage depreciation and how do you manage like recourse versus non-recourse, and do you securitization of the assets or not? Like there's a bunch of things you have to solve to get access to this type of capital at scale. And once we solve that, that allows our business to operate in a really kind of cash efficient way. And we're still able to kind of abstract all that complexity away from the end user.
Right, because from my recollection, you actually have raised kind of institutional capital on the debt side to handle that, like you said, capital expense to buying the equipment. And there's a spread there for the company. Is that right?
That's right.
Okay, cool. All right, so I have another tweet that I pulled here, which is highly relevant for going direct, and I thought it's going to be the kind of subject of my next written piece next month, which is this concept of scale through coordination versus consolidation, right? And so this idea of like inherently decentralized systems, they actually scale through coordination, not through concentration, right? Which like the traditional PE model is through concentration. You centralize everything, you drive costs down as much as possible. Versus a decentralized system, you actually have to do that, which is a much harder thing to do and much more expensive sometimes up front, which is the coordination. And so this is the quote that you had that was interesting. I want to dig into it with you. Okay. You said software scaled because distribution went to zero, manufacturing stalled because coordination never did. So kind of as you think about going from 100 to 1,000 factories, what breaks when it relates to coordination in the systems that you're building? Like what keeps you up at night to actually allow this to scale up to that 1,000 factory mark?
Yeah. I think that the thing that I was calling out in particular with that tweet is manufacturing already is a heavily decentralized activity, right? And when because of that decentralization, there is an enormous amount of coordination cost. And you can imagine, you'll hear examples from any company that's tried to work with manufacturing in the US, which is even getting a quote from another factory on how much it costs to make some product is like a multi-week long adventure. And sometimes you never hear back, right? And like that is the simplest possible thing. You're saying, hey, I might want to give you some money. Is there, what is it going to take? Right. And
try doing that in France.
I'm sure that's worse. Yeah. But it's
you want to give me money? What?
Yeah. It's like people will take offense, right? I mean, literally, like there are categories of manufacturing in America today where you cannot get a quote. And so that's like, so that's pre-production, let alone when you actually have to make something, you know, organize, okay, how many do you need? Where do you want it? What color does it need to be? What, you know, what surface finish do you need on the metal? How many, what are the bore size of the holes? Something, and then you manage the logistics and, you know, managing through a bunch of different intermediaries to get that thing to you. And is it in a distribution warehouse? Is it directly, you know, to your facility? There's so much complexity and coordination that's necessary. And again, like going back to the example of the pencil from Milton Friedman, like there's even a simple product like a pencil has like probably hundreds of suppliers in that supply chain. If you go all the way down to the people who mined the graphite and made the paint and chopped the wood, you know, like manufacturing is this complex pyramid where like the base of the pyramid is just so full of complexity. And then, you know, to get to any product at the top of the pyramid, like let's say semiconductors, like there's just like such a complex web underneath it. Just like that was the thing I think I was trying to allude to in this tweet, which is without a ton of software infrastructure, without a ton of artificial intelligence, without lots more robots, like that coordination cost is never going to get to zero. And so manufacturing has struggled to scale because of that. So, you know, I think obviously I can, you know, turn the mirror on myself and say, hey, well, with Formic, you know, we are going to have scaling challenges, to your point, as the complexity grows, and how are we going to manage that? I think that is absolutely valid. But I think that, you know, even at full production scale, like Formic is still at a much smaller scale than kind of the economy as a whole. Sure. And I think what we found is with a lot of our customers is when you have robots in the production line, the data that's collected from the robots and your ability to coordinate production needs in those factories goes up quite a lot, because you have this kind of layer of direct control over your production. You can reallocate resources much more dynamically and efficiently.
Oh. So you guys, I want to kind of step back here at the beginning stages. You started in 2020. So you're 6 years in, and I saw another quote here that, you know, the mission to give American factories superpowers via robots has proven harder and more meaningful than any of us ever imagined when we got started. So kind of when you were going into this journey, what was is there one thing that kind of surprised you of how hard it's been, or challenge that you just did not foresee?
Oh, so many things. I don't know where to
start. I'm sure.
One of my favorite pictures, as you can see it floating around the internet, is like there's this room full of people who are like disheveled and tired, and there's this banner behind them that says, "We do this work not because it's easy, but because we thought it was going to be easy." And I think that probably describes every startup in the world. Sure. But I think when it comes to robotics, I mean, there are thousands of details like that. So, you know, I can start with the complexity around the robots themselves, right? Mm-hmm. Like, you know, getting a robot to work in a lab is very easy, you know, and I think you were talking about this earlier. Lots of cool companies have demos of robots doing backflips on the internet, but getting that same robot to perform in a manufacturing environment is probably, you know, 100 times harder. And then getting that same robot to perform in a manufacturing environment unsupervised for 24 hours at a time with no human intervention, you know, for months and months is another, you know, 1,000 times harder. And so I think that's really where the complexity lies, is how do you go from, hey, the thing works, to it works reliably, to the thing works reliably and I don't have to be involved. And I think a lot of robotics companies today are really stuck in phase one. So that's one piece. The other piece is, I think, a little bit related to the cultural thing that I mentioned earlier, which is I was surprised how many factories we would go to and say, hey, look, we can solve like such a huge variety of your problems for you. And they would say, no, I'm not interested. Right? Like, it's new. I don't trust you. What is this kind of Silicon Valley newfangled thing that you're bringing to me? I only work with people I know. Like, there's a lot of these kinds of cultural baggages that are hard, that make it hard. And if you look at our website, it's like packed to the, you know, chock full of customer case studies because that is the only thing that's helped, right? And now we can go to any customer and we can say, we'll pull up a bunch of videos and we get instant trust. But you don't get that until so our sales cycle now is like, a week or two oftentimes. When we started, our sales cycle was probably a year and a half, right? Like they didn't believe anything we said. I think that's another big one. You alluded to some of the other things around supply chain complexity, managing a fleet of assets at scale is complex. Incorporating new tasks continues to be a point of complexity because it's easy to look at two tasks that look very similar in two different factories and say, well, the same robot can do both of those things. In reality, there's a bunch of nuance that often gets missed. For example, the human might be inspecting something while they do some task, and you have to be able to make sure that you can do that if you want to actually meet that production need. Or, a round object may be much easier to pick than a square object. Or in the case of like CPG, palletizing looks all the same, but if you're palletizing boxes that are taped shut, that's much easier because you can use suction cups versus like if you look at what they sell in Costco, it's typically these open top trays. And so palletizing open top trays, you just require like a bunch of different tooling and infrastructure. So there are so many nuanced details that you have to know about and get right before you can solve these incremental tasks. And I think my contention is that like the only way to get that information and learn about those things is to be in the field and in production environments. And robotics today has suffered enormously from just having a lack of access to really good training data. And I think the analog that I look at a lot, like the most successful example of robotics deployed at scale today is, I think, self-driving cars, right? You have on the one hand, Waymo's approach, which is you spend $2 to $5 billion to train, collect a bunch of data and train on a new city. And then hopefully after you roll out the service, you can make that money back. Or you have the Tesla approach, which is, hey, I'm going to make a product that people will buy regardless of the AI. And then as I'm getting paid for delivering this product and service, I can collect training data. And it's much more sustainable, and you can get a much larger order of magnitude of data and much more generalizable data if you're getting paid to collect the data instead of if you're paying to collect the data. And so in our belief, I think for robotics, that's really, really critical, is you have to be in the position of getting paid while you're producing useful training data. And I think that's, again, where a lot of the robotics AI labs today are really suffering. Like there's a lot of hype, so there's a lot of people willing to fund people sitting in the middle of San Francisco folding laundry. I think you're very dependent on the whims of investors in that context. And I don't want to build a business that way.
Sure. And how many people is Formic today?
We're about 70 employees.
Cool. I just want to talk just a little bit, just for a minute here, because a lot of folks that are listening or watching are in fact founders or unfounding teams of folks building, obviously, that are touching the real economy. And I thought, especially because I know you have I looked, you have an investing background as well, but could you just talk a little bit about your strategic decisions of how to actually, your financing capital strategy for Formic, both just on the equity and the debt side?
Yeah, I mean, I'll skip all the cliche answers around like find investors that you like, people who understand what you're doing, etc. But I will say one of the big things I made a very conscious effort around with Formic that I learned after being an investor for a long time, especially in deep tech, is that there's a very common trajectory in deep tech companies, which is you bury your head down for 3 or 5 years building some really, really complicated, really complex piece of technology. And then you poke your head up out of a hole and say, who wants to buy this thing? And that usually doesn't go very well because you often, even maybe in a very small way, have misread the market need or the way that they evaluate that product. And you end up with unfundable business or a very low-priced acqui-hire or something like that as a business. What the deliberate effort that we made at Formic was to do the inverse, right? Which is start by not building anything and just going and validating market demand and using everything off the shelf as much as humanly possible. off-the-shelf hardware, off-the-shelf software, off-the-shelf tooling. Even if we have to overpay for it, that's okay. We need to prove that customers want this. And then once we did that, then we felt much more comfortable and confident investing R&D dollars to make it better and make it more efficient and use software to automate a lot of those processes and tasks. That's obviously not feasible in every aspect of deep tech, but I think there's a nugget of truth in that in every context, which is especially very technical founding teams have a tendency to romanticize the solution and not truly understand the problem.
Sure.
So again, that's probably still a little bit cliche of an answer, but I've seen a lot of that in firsthand experience.
And at what point in Formic did kind of the debt market open up for you guys in getting that facility?
Yeah, we in the specific type of business that we were building at Formic, we knew from the beginning that asset financing was a critical enabler of Robotics-As-A-Service. Basically, one of the things that we're selling is access to like hardware, and that costs a ton of money. So I think we started with the idea that this will have a more complex capital stack than your typical software company. It doesn't necessarily apply to every business. I don't think everybody should do what we did, but my second hire was my CFO.
Sure.
And he was the head of asset finance at EY. He built, asset financing facilities for every type of asset you can imagine, from kind of rail cars to billboards, shipping containers. We were able to take some of those best practices and build that into the DNA of the company. And I do think that it is important for founders to at least be educated on the various types of capital available to them. I think too many founders rely on VC dollars only, or in the slightly better case, maybe VC dollars and venture debt only. Both of those come with a ton of trade-offs and are definitely not the entirety of the capital stack. So depending on the kinds of things that you need to spend money on, you should really match up the right type of capital need for the specific type of task.
Great. And so when was that facility then that you guys brought on? I forgot when you announced. I don't have it here. So I was curious.
We built our first asset financing facilities in 2021. Yeah.
Okay,
and then we did our first full scale asset securitization deal, or like middle of 2025.
Oh, cool.
But
great.
We had access to a variety of different kinds of like forward flow programs and like non-recourse asset financing facilities prior to that. Securitization really takes it a step further because it gives you a much larger scale of access and much more flexible capital.
Great. Why do this work? Why are you doing it?
I think, part of it is, I think, just like a boyhood fascination with robotics. I think as a kid, I loved seeing things move and going in and out of factories and seeing how things are made and watching those how it's made videos. So that's like, I think on the like, why do I personally want to do this thing? But I think what we're doing at Formic, I think, is really critically important to like building a world of abundance. Right? It sounds very theoretical, but when you look at it in practice, right? Like I go to these factories every single day. A lot of the products that our customers make, I use in my house, right? Like I have that specific thing and like knowing where it came from gives me just so much more motivation to think about, how do I make this better? How do I make this more accessible to more people? When you look at like poverty around the world, you look at the people who don't have access to basic necessities, when you look at how brittle the supply chain is during something like COVID, where thousands of people suddenly didn't have access to something as basic as toilet paper, right? Like when you talk about aerospace parts, submarine, like any kind of product that really we rely on as a human civilization is built in some factory somewhere. And in my mind, right, like if that whole set of machinery dwindles and fails, right, like human civilization really, really starts to suffer. And there are still billions of people on the planet that don't have access to the basic necessities of life. And I don't think that that's going to magically resolve itself unless we drastically increase productivity in the means of production, basically.
Cool. All right, you ready for a little rapid fire? Then we'll wrap up.
Sure.
All right. Who resists you more, factory owners or systems integrators?
I think system integrators for sure. I mean, system integrators hate us because we're disintermediating them.
That's what I'm looking for.
Yeah.
All right. What best describes Formic? A robotics company, a bank, or something else?
I would say something else. The something else is probably like the largest robot owner and operator. So we are developing robots. We're definitely not a bank, but we have characteristics that look like a bank as well.
Is the current robotics wave better at building robots or making launch videos?
Great question. I'm gonna get some hate mail for this one. I definitely. I think there are. I will say, many investors have told me you need to get better at making launch videos. So maybe that's a deficiency on my part.
Good answer. And okay, you have to pick one. I know it's kind of like hard to do, but if you have to pick one of these, if reshoring fails in the U.S., will because of policy, labor, or slow automation adoption?
I think all of the above. I think that there really are. When I look at the manufacturing economy, there's a lot of risks. Automation adoption is a critical ingredient, but automation adoption is not going to happen by itself. You need companies like ours. You need also a lot of policy changes, sure, I think, in the long run. And I think when you talk to lawmakers today, there's really a mix of people who are seduced by the hype, right? They're like, oh, humanoids doing back with that, those are going to be everywhere, right? We just need to fund a bunch of humanoid companies. To the other extreme of people who are saying, oh, robots are going to take all the jobs and we don't want them. And then there's another kind of camp, I think, in government, which is saying, oh, we only want high value manufacturing. We only want to manufacture chips. We want to manufacture EVs, everything else, like let other people do it. And I think they completely missed the point that you can't manufacture those complex things if you can't manufacture the simple things. Yeah, I mean, I think there's a lot of ways that this could fail.
Who else should I talk to on Going Direct?
And you want robotics companies, or do you want other sectors?
Anyone you think is interesting that's kind of relevant to this theme of kind of decentralization, scaling through coordination, whose work has influenced you?
I'm a big fan of Machina Labs. So I don't know if you are familiar.
I've spoken to Ed.
Guys. You've spoken to Ed. Okay.
Yes.
All right. Well, I love Ed.
I'm going to do another one because I just saw his funding announcement. So
yeah, he did do a funding announcement. There's another guy that I'm a big fan of, Sunny Yu, who's the founder of a company called Fulcrum ERP. They build kind of ERP software for manufacturing businesses. And they're, I think, approaching it in a really, really interesting and unique way.
Cool.
Yeah, lots of ideas come to mind. Let me think about it. I'll send you some names.
Great. How can people reach you?
I'm on Twitter just with my name, Saman Farid, SamanFarid. You can just send me a DM. Or you can find me on LinkedIn. You can find my email on the internet somewhere. Yeah, please reach out.
Great, man. Well, we'll make sure to put those in the show notes. Well, Saman, thank you, my man. Anyone out there looking to release some robots, you know where to find the Formic team. So I appreciate it, and look forward to keeping in touch, and look forward to seeing Formic progress.
Amazing. Thank you so much for having me on. I really enjoyed it.
Thanks, man. Hey, my friends, Jordan here. First and foremost, a sincere thank you and appreciation for all of our early listeners, readers, and supporters at Going Direct. It's really what keeps me going to do this each and every week, because there's clearly a community of folks out there looking to build a Going Direct economy, which gets me super excited. Secondly, if you haven't subscribed, please do so. Our main channel and community is forming over on Substack. The link is in the show notes below. And we'll also be putting out our weekly conversations at YouTube, Spotify, and Apple Podcasts. I hope you all have a great day, and remember to go direct.